Hello everyone, welcome to Rakesh VALASA YouTube channel. In this video lecture, we will discussing about shape functions for a two-noded bar element taking natural coordinates. Let us see the given question. Derive the expression for shape function for a two-noded bar element taking natural coordinates zeta as varying from -1 to +1. Here, the given condition is shape function for two noded bar element. So I'm taking one bar element. This is the one bar element. Each element having two nodes at ends. This is the node 1 at this end. This is the node 2 at another end. Here zeta value is zeta 1 value equal to -1. This is the zeta value, zeta 2 value equal to 1. That is already given in the given question. Zeta as varying from -1 to +1. Let us take uh, let the displacement any point on this element. Let us I am taking this the displacement point, that is p of zeta. The typical bar element in the natural coordinate zeta varying from -1 to +1, that is shown in this figure. Since there are only two nodal values, that is zeta equal to -1 and zeta 2 equal to 1, a linear polynomial is to be selected. Here I am taking displacement any point p of zeta b. The formula is u equal to, this is the displacement any point p of zeta on the given bar element, u equal to alpha 1 plus alpha 2 zeta. This is the equation number 1. Here we are having two nodes, that is at node 1. For example, at node 1, zeta 1 equal to -1. Now substitute in the equation 1, we can get displacement at node 1 u1 equal to alpha 1, zeta equal to -1, so that is minus alpha 2. This is the equation number Roman number 1. Similarly, at node 2, that means zeta 2 equal to 1. This is the another end. Now write the displacement equation u2 equal to alpha 2, that is alpha 1 plus zeta equal to 1 means plus alpha 2. This is the equation number Roman number 2. By using equation number 1 and 2, write in the matrix form, that is displacement vector u1 u2 equal to the remaining terms are alpha 1 alpha 2 is the common terms, you can write here alpha 1 and alpha 2 is the coefficients. From equation 1, that is 1 minus 1, if you multiply this matrix, you can get equation 1 and equation 2, that is u1 equal to 1 into alpha 1 minus 1 into alpha 2 minus alpha 2, that is equation number 1. The second one is 1, this is the 1, that means u2 equal to 1 into alpha 1 plus 1 into alpha 2, that means alpha 1 plus alpha 2. From this equation, the unknowns are alpha 1 and alpha 2. So how to calculate that alpha 1 alpha 2, that is alpha 1 equal to alpha 2, alpha 1 alpha 2 equal to when this matrix goes to outside, that is inverse, that means 1 minus 1 1 1 whole inverse into u1 u2. This is the displacement vector. Now simplify this matrix, that is 1 minus 1 1 1 inverse. For example, if the matrix A equal to ABCD, how to write A inverse? A inverse equal to 1 by det A. Det A means AD minus BC. This is the determinant of A. AD minus BC into, now interchange diagonal elements, that means AD. Write D here, A here. Interchange of diagonal elements. Next, change of sign of remaining two elements, that is minus B. This is the minus C. Now apply the same formula to this equation. So alpha 1 alpha 2 equal to alpha 1 alpha 2 equal to this is the matrix inverse. So write 1 by AD minus BC. 1 into 1 minus into minus 1 into 1, that is 1 plus 1. Next, the matrix is interchange of diagonal elements. Both are 1 1, so no change. Next, minus 1, change the sign. Minus 1 goes to plus 1, plus 1 goes to minus 1 into u1 u2 u1 u2. Now you can also write 1 by 2 into matrix 1 1 minus 1 1 into u1 into u2. Now substitute this equation in the equation number 1. This is equation number 2. What is equation number 1? You can write equation 1 in the form of matrix form, that is u equal to 1 zeta into alpha 1 alpha 2. From equation 1, what is equation 1? U equal to alpha 1 plus alpha 2 zeta. Now write in the matrix form, that is 1 zeta into alpha 1 alpha 2. Now substitute equation number 2 in this equation number 1. Substitute equation number 2 in equation number 1, that is u equal to 1 zeta. 1 zeta means zeta is the natural coordinate. Alpha 1 alpha 2 means unknown coefficients 1 by 2 into matrix, that is 1 1 minus 1 plus 1 into displacement vector u1 and u2. Now simplify this equation. Now multiply these terms. 1 by 2 into 1 into 1 1 minus zeta. Next 1 into 1 1 plus zeta into 1 zeta into u1 u2. You can also write, that is 1 minus zeta by 2. Next 1 plus zeta by 2 into u1 u2. Let us assume, you can also write this is n1, this is n2 into u1 u2. Here n1 means shape function at node 1, that is 1 minus zeta by 2. Shape function at node 2, n2 equal to 1 plus zeta by 2. This is the expression for shape function for a two noded bar element. At node 1 n1 equal to 1 minus zeta by 2, at node 2 n2 equal to 1 plus zeta by 2. You, let us see the how to draw the shape function for this bar element. This is the node 1, this is the node 2. You can write from -1 to -1 to 0. This is the 1. From 0 to 1 means this is starting 0 to this is the 1 increasing. This is the shape function for the given two noded bar element. You can also draw like -1 means you can take below also. From -1 to it reducing 0, next 0 to 1. You can also draw like this. This is the -1, this is the +1. I hope this derivation is very clear to everyone. Thank you for watching. Please do like and subscribe my channel for more updates, and also share to your near and dear friends.